Across the Chicago industrial corridors, the tenant mix changed, and your roof feels it. A lot of these buildings shifted from slower, stable manufacturing to logistics and last mile operations, which means faster fit outs, tighter downtime windows, and a lot more pressure to keep patching instead of planning a clean capital project. The change shows up first in roof access. You've got more service calls for RTUs, makeup air, exhaust, comms, security, cameras, door controls, and all the gear that keeps inventory moving, so the same paths get walked over and over, tools get dragged, and temporary walk paths turn into a scuffed lane that never really resets. Every access point also creates more chances for somebody to cut in a penetration fast. New curbs, conduit, gas lines, equipment swaps, re-room layouts, all of it happens with a schedule that favors speed, and the flashing details don't always match the membrane system or the insulation thickness that's actually on that roof. You end up with a curb that looks fine from 10 feet away, but the corner buildup sits wrong, the termination height barely clears, or the tie-in lands right where movement concentrates. Hoods change too, and you can't see that from the street. Conditioned warehousing pushes heavier rooftop equipment, curbs concentrate weight in small zones, and vibration travels into attachment points, especially near long runs of duct or anything that cycles hard during peak delivery windows. If that equipment sits near a seam or a termination line, you get repeated stress in the same spots, and it doesn't need to be dramatic to add up. Then there's compaction and ponding, which is where the paper scope usually misses. Repeated traffic crushes insulation near units and along service routes, minor deck deflection starts reading as new low spots, drains that used to keep up now hold water longer, and water sits where it never used to sit. Longer water residence time doesn't just raise leak risk, it changes how seams and flashings behave when the next temperature swing hits. Moisture hides under surfaces that look completely normal. That insulation around curb clusters, at perimeters, and at tapered transitions can sit there quietly until freeze-thaw reopens the same stress points, then your pull test numbers start failing like the membrane suddenly aged 10 years in one season. That's why EPDM fails more often in these corridors. Disturbed seams and flashings don't love repeated traffic, adhesive performance shifts around heat sources and rooftop activity, and edge details take more abuse when roof access isn't controlled. For Q2, measure instead of guessing. Map the actual traffic and service routes, moisture scan the curb clusters and perimeters, take core cuts at low spots and along repeat leak lines, and document perimeter versus field performance so you can defend the scope when ownership asks why a small repair turned into a real project. Click on the link below and contact Structural Solutions Chicago.com for a roof assessment. Stop patching the symptoms and get the data that explains the source.